All right, let's dive in. Today, we're tackling a topic that's absolutely exploding right now, especially in the world of pharmaceuticals and life sciences. We're talking about AI and machine learning.
It's everywhere you look these days, and for good reason.
Exactly. And to really get a solid grasp on it, we're turning to a fantastic resource, the Pharma AI Academy, the brainchild of Ulrich Jurgensen.
He's really passionate about making AI accessible to everyone in the pharmaceutical world. Ulrich saw this kind of knowledge gap, where people were hearing all this buzz about AI, but didn't have the tools to really understand it or apply it. So he decided to do something about it.
And thank goodness he did. Because, let's be honest, AI can feel a little intimidating, especially when you're first starting out. So our mission today is to unpack the core ideas of AI and machine learning. We're going to break down the jargon, look at how everything fits together, and hopefully demystify some of the concepts that Ulrich lays out so well.
We're going for that solid foundation, that shared vocabulary.
Right, and we're going to do it all through the lens of Ulrich's expertise.
Which is fantastic, by the way. He's got a knack for explaining these things in a way that really clicks.
Totally agree. So, to kind of set the stage, let's look at the learning objectives that Ulrich lays out in his material. He wants us to understand what AI actually see how AI has evolved over time. And of course, we'll dive into machine learning, deep learning, and how they relate to each other. And finally, we'll touch on that super buzzy area of generative AI.
Which is just blowing up right now.
No kidding. It feels like every day there's something new happening in that space.
It's really exciting stuff.
It really is. So whether you're completely new to this world, maybe you've heard the terms but don't really know what they mean, or if you've got some experience under your belt, this deep dive should give you a clearer picture of how it all works. So to kick things off, let's tackle the big one. What is artificial intelligence? How does Ulrich define it?
Well, in his words, AI is essentially the simulation of human intelligence in machines. It's about giving computers the ability to learn, reason, and solve problems.
Like, think for themselves.
Exactly. Tasks that typically require a human brain.
Right, and this isn't some sci-fi future we're talking about. AI is already here, working behind the scenes in so many tools we use every single day.
Oh, absolutely. I mean, think about ChatGPT and Copilot. They've kind of taken center stage lately. And, they're pretty cool. But Ulrich points out that AI is even more pervasive than that. Spotify recommending music you might like. Netflix suggesting what to watch next.
Even that Vivino app that identifies wine from a picture.
Right, all powered by AI.
It's pretty wild when you stop and think about it. And speaking of history, let's take a quick trip down memory lane with AI. Ulrich lays out a really interesting timeline in his material. So where does this story begin?
Well, way back in 1950, Alan Turing, a brilliant mathematician and computer scientist, asked a really foundational question. Can machines think? Now, this wasn't just some abstract pondering. It actually led to what we now know as the Turing test, which is a way to evaluate a machine's ability to exhibit intelligent behavior.
So can it fool a human into thinking it's another human?
Right, and that's still used today as a benchmark for AI.
And that same decade, Marvin Minsky described the first functional neural network.
And that, as Ulrich emphasizes, was a crucial precursor to machine learning as we know it today. It's basically the foundation for how machines can process information in these interconnected layers, like a simplified version of the human brain.
So they were already thinking about how to mimic the brain back then.
Oh, yeah, definitely. And then in 1956, a pivotal year, we have the Dartmouth Conference. This is where the term artificial intelligence was officially coined, where it all began, as a formal field of research.
Like the birth of AI.
Exactly.
But then, in the 60s and 70s, things hit a bit of a snag.
Right, we enter the so-called AI winter.
Like a period of disillusionment.
Yeah, there were a few reasons for it. Computer power was much more limited back then, and there wasn't as much data available to train AI models, so the initial results were not as impressive as people had hoped for. And, funding dried up, and interest in AI waned. It showed that they were still a long way from achieving those early, lofty goals.
But the spark wasn't completely extinguished, right? Because in 1997, we have a huge milestone. IBM's Deep Blue beating Garry Kasparov, the reigning world chess champion.
That was a big deal. I mean, up until that point, most people thought that computers could never really compete with humans in a game as complex and nuanced as chess. But Deep Blue proved them wrong. It was a really powerful demonstration of how far AI had come.
Like machines can think strategically?
Right. And then a few years later, in 2011, IBM's Watson made another splash by winning Jeopardy!
Which, if you've ever watched Jeopardy! You know it requires a totally different kind of intelligence.
Oh, absolutely. It's not just about brute force calculation like chess. Watson had to understand natural language, like how we humans talk, interpret those tricky Jeopardy clues, and quickly retrieve information from this vast knowledge base. It was a huge leap forward in AI's ability to process language and knowledge.
If that wasn't impressive enough, fast forward to 2016, and we have AlphaGo, developed by what's now Google DeepMind, defeating the world champion Lee Sedol in the game of Go. Now, Go is even more complex than chess, right?
Oh, way more. It's got an insane number of possible moves. What was really groundbreaking about AlphaGo was that it didn't just rely on brute force calculation. It actually learned to play the game through deep learning, and it even started making moves that surprised the human experts. It almost looked like it was developing its own intuition about the game.
Wow, that's really something. And then, more recently, November 2022, OpenAI releases ChatGPT, and that seemed to change everything, didn't it?
Big time. ChatGPT, as Ulrich describes it, was like this first widely accessible general-purpose AI that could hold a conversation with you, answer your questions, generate text, all in this really natural, human-like way. And even though its knowledge was kind of limited to data up to a certain point, it just blew people's minds.
Yeah, just like everyone suddenly realized that AI was no longer some futuristic fantasy. It was here, and it was ready to chat.
And since then, the floodgates have opened. Ulrich points out that we've seen this explosion of new large language models. The pace of innovation is mind-blowing.
It's almost hard to keep up.
I know, right? It feels like every week there's a new breakthrough.
So we've got this historical context, but Ulrich makes a really important point that I think is key to understanding the fundamentals. AI is not just one algorithm. Can you unpack that a bit? What does he mean by that?
So while algorithms are obviously super important in AI, and they are essentially the sets of rules that allow computers to learn and make decisions, AI is so much bigger than just that. It's about the design of entire systems, how you select and prepare the data that the AI learns from, how you evaluate its performance, the whole structure that brings all those pieces together. The algorithm is like one piece of the puzzle, but it's not the whole picture.
So it's not like there's this magical AI algorithm out there that does everything.
Nope, it's way more complex than that.
Makes sense. Now, let's focus specifically on the pharmaceutical industry. Ulrich is really excited about the possibilities of AI in this space. What are some of the areas where he sees the most potential?
Well, he's particularly enthusiastic about the potential for faster drug discovery and development. AI is already being used in different stages of that process, and it's showing a lot of promise. And initially, it was easier to apply in those areas that weren't as heavily regulated. So, they started there and gradually moved towards those more regulated aspects.
So the regulatory landscape kind of dictates where you can start.
Right, it definitely plays a role. But beyond just speeding things up, AI can also help us make sense of the mountains of data that exist in the pharmaceutical world. Think about all those clinical trial results, research papers, patents, treatment protocols. It's overwhelming for humans to try and sift through all that information. But AI can analyze these massive data sets incredibly efficiently, potentially uncovering hidden connections and insights that we might have missed otherwise.
Like finding those hidden gems in the data.
Exactly.
And what about personalized medicine? That seems to be a huge area of interest.
Definitely. Ulrich is a big believer in the potential of AI to tailor medical treatments to individuals. Imagine analyzing someone's genome and using that information to predict which drugs will be most effective for them, or even developing entirely new therapies targeted to their specific needs.
That would be incredible.
It'll revolutionize how we treat diseases. But of course, with any powerful technology, there are challenges.
Right. What are some of the hurdles that Ulrich sees?
Well, one big one is the regulatory landscape. It's constantly evolving as AI becomes more sophisticated, and regulatory bodies around the world are still figuring out how to best oversee its use in healthcare and drug development. It's a moving target, and that can make it difficult for companies to know how to proceed.
Yeah, keeping up with the regulations is definitely a challenge.
Another key point that Ulrich emphasizes is the need for transparency in AI outcomes, especially in a field like pharmaceuticals, where decisions can literally have life or death consequences. We need to understand why an AI system is making a particular recommendation, why it's suggesting a particular treatment. The idea of a black box where we don't know how the AI arrived at its conclusion, that's just not acceptable in this context.
Explainability is key, right?
Absolutely. And this is where education comes in. Ulrich founded the Pharma AI Academy because he saw this real need for people in the pharmaceutical industry to understand the fundamentals of AI. If we want to use this technology safely and effectively, we need to know how it works, what its strengths and limitations are.
It's about empowering people to be informed users of AI.
Exactly.
Now, to help us visualize the relationship between all these different concepts, Ulrich uses a really helpful analogy, the V diagram. Can you walk us through that?
Sure, so picture a big V. At the top, the broadest part is AI, the overarching field of creating intelligent machines. Then as you move down the V, you get to machine learning, which is a subset of AI. Further down, you have deep learning, which is a subset of machine learning. And at the very bottom, the narrowest point of the V, you have generative AI. So it's like a hierarchy with each level building upon the previous one.
Okay, that makes sense. So machine learning is a specific approach within the bigger world of AI. What makes it different from other approaches?
The key with machine learning is that it'll allow systems to learn from data without being explicitly programmed for every possible scenario. Instead of having to write down all the rules and instructions manually, you feed the system a ton of data, and it figures out the patterns and relationships on its own. It's learning by example, essentially.
Like, show it a bunch of cat pictures and it learns what a cat looks like.
Exactly. And within machine learning, Ulrich talks about three main methods: supervised learning, unsupervised learning, and reinforcement learning.
Okay, let's break those down.
So with supervised learning, the data that you use to train the model is labeled. For example, if you want a system that can tell the difference between cancerous and non-cancerous cells, you give it a bunch of images that are already labeled as either cancerous or non-cancerous. The system learns to associate certain features in the images with the correct labels, and that it can use that knowledge to classify new images that it hasn't seen before.
So it's like learning from a teacher who already knows the answers.
Pretty much. Then you have unsupervised learning, where the data is unlabeled. In this case, the goal is for the system to find hidden patterns or structures in the data on its own, without any guidance. This could involve grouping similar data points together, identifying outliers, or reducing the complexity of the data.
So it's like, here's a bunch of data, go figure it out.
Exactly. And then there's reinforcement learning, which is kind of like training a dog. You have an agent that's interacting with an environment, and it gets rewards or penalties based on its actions. Over time, it learns which actions lead to the best outcomes, and it starts to develop strategies to maximize its rewards. AlphaGo is a great example of this, where it learned to play Go by playing millions of games against itself, getting feedback on whether it was winning or losing, and gradually refining its strategies.
It's like learning by trial and error.
Exactly.
Okay, so we've got machine learning and its different flavors. Now, what about deep learning? How does that fit into the picture?
Deep learning is a type of machine learning that uses artificial neural networks. And these networks are inspired by the structure of the human brain. They have multiple layers, hence the deep, and these layers allow them to learn really complex patterns from data. It's like having a brain with many different processing units, each specializing in a different aspect of the problem.
So it's like a more powerful version of machine learning.
You could say that. Deep learning is particularly good at things like natural language processing, where you need to understand the nuances of human language, image recognition, which is used in everything from medical imaging to self-driving cars, and even really complex tasks like predicting protein folding.
That's pretty incredible. And finally, we have generative AI. Where does that fit into this whole hierarchy?
Generative AI builds on deep learning, and it's all about creating new content. It can generate text, images, audio, even video. Essentially, it learns the underlying patterns in the data it's trained on, and then uses that knowledge to create something new.
Like those deep fakes you see online.
Exactly. And ChatGPT is another example of generative AI. It's generating text based on the massive amount of text data it was trained on. And Ulrich really emphasizes the importance of the data that's used to train these generative models, because if the data is biased or incomplete, that bias will be reflected in the output.
So garbage in, garbage out, as they say.
Pretty much.
So to recap, we've covered a lot of ground here. From Ulrich's perspective, he really wanted to give everyone a solid understanding of what AI is, how it's evolved over time, and the incredible opportunities it presents for the pharmaceutical industry.
He also highlighted some of the key challenges, like navigating the ever-changing regulatory landscape, ensuring transparency in AI outcomes, and making sure that people in the industry are properly educated about AI.
And we explored the relationship between AI, machine learning, deep learning, and generative AI. We saw how they all fit together, how they build upon each other.
And Ulrich's message, I think, is that while all this can seem really complicated at first, the fundamental concepts are actually pretty straightforward.
Yeah, and that's what we've tried to do today, make it all a little less intimidating.
So if you're working in the pharmaceutical world, or you're just interested in the future of medicine and healthcare, having a basic understanding of these concepts is becoming increasingly important.
Today, we've gone from that basic introduction to AI, a little history lesson, looked at its potential and challenges in pharma, and then really dug into the differences between AI, machine learning, deep learning, and generative AI.
And if you're hungry for more, Ulrich has a treasure trove of resources over at the Pharma AI Academy.
Absolutely. You can find it all at www.pharmaacademy.com. There are quizzes, more videos, all sorts of great stuff to deepen your understanding.
So take that knowledge, think about the massive amounts of data in the pharmaceutical industry, and ask yourself, what incredible breakthroughs might be just around the corner waiting for AI to unlock them?
It's an exciting time to be in this field, that's for sure. Thanks for joining us on this deep dive.
Absolutely, it's been a pleasure.